Video started. Apologies about that. Welcome to Paul Sound. Thank you for coming. I make speakers, like the ones you just heard. And there's one in my backpack. I forgot to get it out. I was gonna get it out. This little doodad. Pretty cool, right? It's a little Bluetooth speaker I made. Comes apart. Finish is really bad. It's not the final version. Not even remotely close. And those right there, I don't know if you can see it right next to the microphone. It's pretty dark there. They're pretty well hidden. We have some electronics going on in them, and that's what I'm here to teach is some of that electronics that go along with that, how to make your speaker. You know, you want to make speakers, we're gonna show you everything. I'm gonna show you everything from, you know, how to select stuff to this software here called winisd. Oh, whoops, I forgot we gotta do this. Yeah, we're gonna show you anything from how to select a driver to this software called winisd. Yeah, let's get right into it. So let's say I'm a dude and I want some speakers. I'm probably gonna go to Amazon and do a search for speakers, and as you see, you know, we get some of this crap here with these, you know, robots, whatever. I mean, if that's you, you know, you want to talk, you don't have any friends to talk to, you know, get one of these, I guess. Then okay. This is Bluetooth 4.2. That's decent. It's got bass radiators. I'm guessing they are talking about what did we call those? I'll remember what we call those. But yeah, look here. High quality, crystal clear sound, distinct mids, blah 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 blah. Louder. So it gets loud. It gets louder. More bass, distortion free. There's no numbers though. They don't even put numbers on these things anymore. This is the only number we've got, is how many milliamp hours the battery has. But they haven't even told us the voltage of the battery, so we don't even know what the total power of the battery is, because in order to figure out how much power the battery actually has, you need the milliamp hours and the voltage. Anyways, let's keep looking here. They had this guy, the JBL Flip, which I don't know. I've heard a few of them. They could have done better. Again, we only get one number here. How many milliamp hours the battery is. And that doesn't tell us anything at all. So let me go back. Go back. Now Amazon's getting weird. Maybe because I'm recording it. Am I recording? Yeah, I'm recording. Okay, cool. Okay, this actually looks like what I think of as a speaker. Near field monitor. And 42 watts. So we got another number here. We got 42 watts. So this is actually, it doesn't have a battery. You have to plug it in here. And it's got 42 watts. That's it. It just says how many watts it has, which again isn't enough information to figure anything out, unfortunately. Let's keep going. What brand is this edifier? This one is the Amazon's choice as well. 120 watts. Again, wattage alone isn't enough information to tell anything. So that's what this is all about. I'm going to introduce a concept to you guys called decibel. Now, if you want to know actually how loud these speakers get, it wouldn't be in terms of watts. It would be in terms of decibel. Yes, wattage is important in determining the total decibel, but it's not enough to determine the total decibels output. So I'm going to go to a site that I enjoy shopping for speakers and stuff on. The name of the site, and I'm not being endorsed by these guys or anything, but but the name of the site is partsexpress.com. It's a great place to shop for speaker building components and speakers. They've got these are pretty great, these bookshelf speakers. I wouldn't out the door recommend any of these because I've never listened to them, but just to show, you can scroll down here and it's going to tell you 30 watts RMS, 60 watts max. It's given this frequency response, which who knows, but then we get this measurement, which is very important here, this sensitivity. This is the first time we've actually seen this dB. This is decibels. This is telling us we're going to get 84 decibels at 1 watt and 1 meter. So now we've got some kind of interesting math going on. We've got wattage and we've got decibels. So wattage is the amount of power that goes into something. You can even think of horsepower, like how much a horse can lift in a certain amount of time, how much power it takes to lift something a certain distance, how much power it takes to move something a certain distance, how much power is in a battery, how much power is coming out of a battery. So yes, power is an important measurement. It's not the only important measurement. The other one we've got here is this sensitivity, the decibels. And so decibel is kind of an interesting mathematical formula to convert wattage into decibels. That's not to say that this sensitivity number here reflects how many watts that the speaker can do. This sensitivity number reflects how loud the system is at 1 watt. So there's a little mathematical formula. I'll go ahead and show this. And just to be sure everybody can do it, we're going to do it in Google. We're going to do 20 log of the power. And this should come up as 0, which is good. So let's say we want to figure out the maximum that these speakers can do, these Dayton Audio B452 4.5 inch. Was it Bluetooth? Bookshelf speakers. So we've got this 84. That's how loud it's going to be at 1 watt. So at 1 watt, we put a 1 into this equation and we add 0 to it. So we take 84 plus 0 and we end up with 84, just to kind of verify that this is what we're getting at 1 watt. And then now let's take the 30 watts and let's figure out what the maximum output of this speaker system is going to be. So instead of the 1, we're going to put 30 in here. And this gives us 29.5, which I think I did the equation. Is this log base 10? Let me just double check here. Let me just double check real quick. 30 divided by 2. 1, 2, 3, 4, 5. 5 times 3. Okay. So the equation should be 10 log of 30. My bad. It's 20 log for the voltage and 10 log for the power. Okay, so we got this 14, and we're going to add this 14 to the 84. Just make sure it was 84. Yes. 98. So this is the maximum output of the system. At, if you take these speakers and you turn them all the way up, you're going to get 98 decibels. 98.77, whatever. Alright, so this is $27. It's not very expensive. So I'm not trying to bash this product or anything, but let's just go into something that we're going to be able to get quite a little bit louder, and we're just going to do the same equation again. This one's decent. This works. The 18-inch Neo, and they're going to have they had to do it. They just had to. Okay, it's 8 ohms. Never mind. All right, so now we've got 97 decibels and you'll see this 2.83 volts. This actually happens to be 1 watt if your impedance is 1 ohm, so we're just going to ignore that for now. So this is actually 97.1 decibels at 1 watt. Now what was this other speaker doing? It was doing 98 decibels at its maximum power at 30 watts. Now this guy can even get more power too. It can get up to 800 watts. So let's just do that. 10 log 800. And you see we get 29, and then we're just going to add the 97.1 to that. And so this gets up to 126 decibels, which is what you would expect from an 18-inch Pro woofer. And so we're gonna hold on here. Decibel chart. Get one of these, and we're gonna put some terms to this. 1 minute, 1 hour, permissible. Ear damage. We don't care about ear damage. Pain. So 120 decibels is pain. And what did this thing do? 126 decibels. So this thing goes past pain. That's how loud this is. The other one was 97, so it's considered basically very noisy. And how many decibels you want depends. Again, this is a measurement at 1 meter. So as you go further and further away from the speaker, this number is going to go down. So obviously the size of the place, the size of the crowd and everything is going to determine how many decibels you want. But decibels is really just a comparative factor. We use it to compare one speaker to another. And can kind of, did this even say on this? Basically, what I've been led to believe is 10 decibels is basically almost a doubling of the sound in terms of human hearing. 3 decibels isn't noticeable. 3 decibels is not noticeable. 5 decibels is the minimum noticeable. I keep clicking on all this shit, and it's not even gonna. Well, anyways. Oh, look at that Italian conversation. Well, I don't know. If you have any questions about decibels, do let me know. I think I'm just gonna go straight into the next portion of this without any editing, and then maybe do some editing later. Maybe I'll post up the raw video too. I don't know. See how long my computer can keep recording. Anyways, so remember how on that this one we looked at, we finally found something that gave frequency response information, and these are your frequencies. And the spectrum goes, human hearing is 20 hertz to 20,000 hertz. So it would be ideal if AirTweeter at least could get most of that in there. And most people I've heard can really only hear up to 16,000 hertz. If you're a musician or something, you'll be able to hear 20,000 hertz though. That said, a lot of drivers, even ones that list 16,000 hertz, you can barely tell the difference between them and 20,000 hertz drivers. So we have this 85, which really isn't that low, but it doesn't tell us what mechanism they used. I'm thinking they used the -3 dB point, which again, -3 dB isn't even noticeable, but a lot of manufacturers like to use that as their referencing criteria. So this 20,000 hertz will actually be 3 decibels quieter, potentially 3 decibels quieter than something right in the middle, like 1,000 hertz will be what we call 0 decibels, is the baseline. And then this 85 hertz again is going to be 3 decibels quieter than the baseline of 1,000 hertz. But they didn't say that they were using the a 3 decibel point, so we just kind of assume it for now, hopefully, and then we get these speakers, and maybe we can use that information to pair this with the subwoofer, and who knows, maybe this is the minus 10 dB point, and for that you would want to use a different crossover on your subwoofer. But anyways, these are probably decent speakers. I bought stuff from this brand, this Dayton Audio, nothing this cheap though. I didn't even know they made stuff this cheap. But anyways, let's go through the process of what I do when I like to design speakers. I look through these guys and I'll pick one, whatever. This is actually the replacement for the Bose 901 series. The classic woofers, I didn't like the way they really stacked up. The reference series are great though, so let's just pick one of these reference series. And all right. So this website shows some cool stuff here. Optimum cabinet size determined by using Basebox 6 Pro high fidelity suggestion. So what they've done is they've taken, there's a crap ton of parameters here, and they've taken these actually and put them into this software to determine box volumes and sealed F3s. And so what this F3 means is this is the frequency where that whole minus 3 decibels I was talking about happens. And so we can get a pretty good figure on how this speaker is going to work, because we've got this information now. We know that this is the minus 3 dB frequency is going to be 63 hertz, and we know that we need a box with an internal volume of 0.45 cubic feet. Now, if you want to be kind of anal about it and you want to actually see what things look like, what you can do is you can download Basebox 6 Pro yourself, or you can get this free software that I like using called winisd beta, and this is actually 0.44 version, and they've come out with future versions. They've come out with an alpha since then, but none of them seem to really work that well. So you saw before, I just went up here and I clicked on this and I copied the name. Then I scroll down a bit and I get to these fairly small parameters. And, I can talk about what all these are. You can kind of figure them out. You can research them on your own if you're interested. But that's not what we're doing. What we're doing is, I should go through that process. We're going to just take these parameters and shove them into the software, and the software is going to tell us what kind of response we're going to get for every box. And you see, this software is kind of intuitively designed. This red line here is the flat line. This is your 0 decibel point. And you see everything below here is going to subtract some decibels. And ultimately, this is from that sensitivity measurement, the 86.8 decibels, and how much power we're going to put in there. And you see we can get actually SPL calculations too, as well as just the gain. But for now, we're going to, there's a ton of drivers programmed into this software, but we don't care about that because we can't actually buy any of those. So we want to add our own. And what we're going to do is click New, Own Drivers, and then just click New here. And you can see there was a bunch I entered in there already, and we just paste in that. And then over in the QTS, I'm literally just going from this to this. I'm just processing the information and pumping it in there. Now make sure for these things that your VAS, you can change this to liters by clicking on this thing here. And for this site, pretty much everything on Parts Express is gonna give you feet squared, but that's just something you want to be aware of. Make sure your units are the same. Hertz you're not going to be able to change. Ohms you're not going to be able to change. Ohms is actually up here, or this is the RE, my bad. So that one's 6.5. The LE is 0.68, and you could get a bunch of these in wrong. The only ones that really matter are the QTS, VAS, and FS. Everything else is just kind of interesting to know and would be useful to note. Even, the size diameter isn't really that important. The QMS and the QES are actually added together through this ridiculous mathematical formula to get the QTS, which is the total of the QES and the QMS. And you see we got this SPL here. We want to make sure that we either get the 1 watt, 1 meter, or if we're 8 ohms, then it's okay to use the 2.83 volts, because 2.83 volts at 8 ohms actually equates to 1 watt. But if we have the 2.83 volt and 4 ohms, we need to subtract 3 decibels from this sensitivity number. We're not going to have to do that here. I might show you an example. I might try to find a... Let me see. The 4 ohm, I think they typically do that here. Okay, so yeah, you see this one, the impedance is 4 ohms, and the sensitivity is 86.2 at 2.83 volts. So we're actually going to have to knock 3 decibels off of this 87.2, because we're going to have half the power going through it. So yeah, we would just take this 87.2 and subtract 3, and we're left with 84.2. But anyways, we're not going to have to do that with this guy because it is 8 ohms and 2.83 volts. So it's 86.8 decibel at 1 watt. And this software specifically wants it at 1 watt, not at 2.83 volts. It just so happens that 2.83 volts is 1 watt into 8 ohms. Anyways, let's finish getting things in here. I like to use the RMS power instead of the max power, but it is kind of optional. You'll find speakers can kind of diverge from what power measurements they've been given. Amplifiers, though, as long as you're buying the amplifier from the designer, you're going to get a pretty accurate rating of what kind of power the amplifier can do. Z was 8. Z is that 8 ohms I was talking about. And then SD, that also happens to be in centimeters squared. Okay. So we've entered. Okay, yeah, I did that pretty quick. You want to hit OK and then cancel and then close right after you do that, and then you go back over here to own drivers, and we should see it in here. For you, if it's your first one, it'll be the only thing you've put in so far, and this is it here. Dayton Audio RS225 8-inch reference woofer, and we can even click here to show the driver parameters while we're punching it in. And anyways, we wanted to see what one of these woofers will do in a normal box. You can go to the isobaric compound pair, and we can actually even adjust any of that later, but the only thing we can't adjust is whether we use a closed vented or a fourth order bandpass. Now it kind of messed up the vented, but it shows this picture over here. Okay, so this has got a port in it. It's got that bass reflex design, and then the fourth order bandpass. It's kind of interesting. It has a sealed box, and then in front of it, it has that ported side of the enclosure. And then there's 6 order, where there's 2 full enclosures with tuned ports on either side. And there's more advanced types of enclosures once you get into horns. Once you get into horn theory, we can do any of that, but I recommend closed box because a closed box is pretty versatile. You'll be able to change what woofers you put into it without really impacting the sound too much. Now, so we've just made our closed box, and this software automatically decides, based on a few things, what volume to use for the enclosure. And this is in cubic feet, and again, I can change it to liters, cubic meters, cubic inches, and it attempts to get a QTC of as close to 0.71 as it can. And what that means is that the enclosure is critically dampened, that the whole speaker system is critically dampened. So you're not going to get any resonances, any overdampening, that kind of thing. So this would really be the ideal enclosure to use for this driver, but if you wanted to, you could reduce the size of it somewhat, and you'll see that this shape of this curve changes. And I'm just using the up and down arrow keys to change the size of this enclosure. And you see this QTC number changes as well. This is your dampening factor. And really the thing to watch out for when doing this is really there's no reason to increase the size of the enclosure. It's not going to give you too many benefits. It will extend your F10 frequency out slightly, but you're going to have to add quite a bit. Look, I've already way more than doubled the volume of this box, and we haven't really seen too much improvement. The F3, this purple line, is staying pretty much the same no matter what I do to this sealed box, and that's how you can tell there's really some versatility in the sealed box. Whatever, if I decide I don't like this 8-inch woofer anymore and put in a different 8-inch woofer, it's going to do just fine, as long as I don't have something ridiculously large or something ridiculously small. And now let's go back to making it smaller. I generally don't recommend going above a decibel of impact of overdampening, overdampening. So this little spike here is caused by overdampening. And I forgot to even mention that all of these, so these are all frequencies. So this is your frequencies, and this is your decibel response to those frequencies. You'll kind of figure out what that means. So this really shows the image represented response of the speaker system, and you can find the F3 here is 52 hertz, and if we look at the website, it was saying if we use a 0.45 cubic foot box, we'll get 63 hertz or something. And to kind of verify the math, let's just make and actually, okay, so we got an extra decimal there, so yeah, it's somewhere around 60, whatever. I generally go by what winisd says over what Basebox Pro 6 says. I don't know, maybe they have slightly different equations in them and so forth. This kind of has the oldest equations, and I may have typed something in wrong, who knows. VAS 2 foot, that was pretty big. That's pretty big. Anyways, so I can go over here to plot, and I can tell it how much power I want to put into the system. And then I can go over here to SPL, and you can see as I increase how much power I put into it, now that whole line is actually moving up. And I can even change my distance, and you can see as I increase my distance, it goes down. So what was the max power? It was 80 watts. So let's just put 80 watts into it. And then let's just, for shits and giggles, take another driver. Take maybe this 10 or this 12. Oh, we do have a pro driver in here, so that might be too sensitive. So this is the 96.4 decibels that I was talking about. The pro drivers can do. And we're just going to do a closed box again and change the color of it. So the green one is the new guy that we just put in, but we need to turn the power up, and the power goes up to 500 watts. So right now we're at 13 watts, and we're way above. It doesn't even matter what the low end response was, we can equalize it, and this guy is going to be louder. So we can keep going up and up, and this should go about up to 130. We can change the remember somewhere in here. Oh, jeez. We're doing such a bad job of this. We can change the scale. Options. Here we go. Upper dB limit. We're going to set that to 140. And we just keep going up and up and up. Just 500 watts. We went over. So yeah, this isn't even a comparison, really. This is ridiculously louder than the other speakers. More than 106 to 124. It's something like 15 decibels louder. It's probably gonna sound 3 times as loud, really. Yet we go here to the gain and compare them, and then obviously the Dayton is better because it has a better F3, but this is just louder. Whatever determines its betterness, is all a ton of things that you should just be considering when you're deciding to buy speakers. And these aren't things that manufacturers are going to show, but you see that the volume is bigger on this one, so this one's going to make a bigger box. You can actually go into box shape, and it does all of this stuff. So here's what I use: 3/4 inch wood, and then I don't know, 10 inches, whatever, 15. Oh, there's an optimum button, so let's just hit that, and then yeah, there you go. Tells you your width, height, and depth that you need, whatever. Now let's take back this Dayton that we were working with here, and we're gonna oh shit, which one was it? This one, 8-inch reference woofer, and we're gonna make a vented box this time instead of a closed. And you can see this one already comes up a different color. It comes up green, and you can see this response has been lowered. We get this lower F3. We get all the way down to 30 hertz now, which I think is pretty accurate. The website was saying 36 hertz, so we're still kind of in that same ballpark. But you look at the box has gone up to 1.642, so it's almost tripled in size. Well, not quite tripled, but yeah, almost tripled in size, whatever. Oh, I'm getting tired. And we can do a 4th order box, and it's going to automatically optimize it. You see, this is actually really close to the ported box, which is kind of interesting, but it also cuts off the high frequency response, and this is why it's called a bandpass, because it has a low pass filter and a high pass filter, whereas these other 2 types of boxes just have a high pass filter. Oh, I'm starting to spew like engineering terms and shit. I've been making videos too long. Alright. How long has this been? I don't even know. Anyways, yeah. So this box has got, we're going to add these 2 together, 0.798 plus 0.566 is slightly smaller than the ported box, which is in general what happens. The bandpass box is gonna give you some better, arguably better. Some people try to argue, but the bandpass is gonna do better. It's gonna give you more transient bass. It's gonna have more attack, more punchiness to it. You can kind of tell by the design of this that the ported box uses waves from the back of the box and delays them in time half a cycle so that they'll be in phase with waves from the front of the box, and so you get an attack loss and a decay loss of exactly 1/2 of the cycle, which if we're looking at the tuning frequency is what's going to 30 hertz. So that's not that bad. That's 1/30th of a second, which is why people can use these and be passable. But anyways, that's enough for me now. If you have any questions, don't hesitate.